Hi. So I'm going to talk about some work I've been leading to help land and wildlife managers in Washington and British Columbia incorporate climate change into their management of transboundary wildlife connectivity. So connectivity, for those who are unfamiliar with the concept, is just the degree to which a landscape facilitates the movement of the organisms and ecological processes within it. So a landscape with relatively high connectivity, it's pretty easy for species and ecological processes like pollination or other processes to move through the landscape. And a landscape with low connectivity, it's difficult for things to move. Why do we care about connectivity? We care because movement is key to the health of species and ecosystems, and this is especially true under climate change. So species need to move on a daily basis. They need to find food, they need to find cover. They need to move on seasonal basis often to find wintering grounds, breeding grounds, and they also need to move especially under climate change. So adjusting their ranges to track areas of suitable climate across the landscape is pretty much the primary way that species respond to climate change. It's how they've always responded to climate change, and it's how they're responding now. So species have been moving for the past century about 11 meters upward in elevation per decade and 17 kilometers poleward per decade, and that's probably slower than they actually should be moving. They're probably lagging behind the speed at which they need to move because there's all this stuff in the way, like cities, and there's roads, and there's agricultural areas. And they're going to have to move really, really fast because climate change is proceeding at a pretty unprecedented pace. And so in addition to all these little things in the way, they also have some political borders they have to cross. And these can actually pose some pretty special cases of barriers to climate-driven movement. So in the very worst case scenario, we have something like this, which is a wall between Mexico and the US. So this is running about east-west, which is directly in the way of anything that's wanting to move north out of Mexico into the US, and is going to have to deal with this. And then where we are here in the northwest, it looks way better from pretty high up there in like maybe 50,000 feet. But if you zoom in on the Washington-British Columbia border, it's not quite as easygoing as you might think. So our land management isn't necessarily being coordinated across the border. So we can be having parks or areas that are in protected status on our side of the border, or vice versa, that are not in that status on the other side of the border, and you've got like timber cuts going on. A really good example of this is in the Okanagan Valley. So here is sort of the northern terminus of the Columbia Plateau. Not much really going on. There's some grazing and such going on our side of the border. On the Canadian side of the border, this is like the Palm Springs of Canada. So this is where the Canadian snowbirds go. They have vineyards, they have retirement communities. The southern edge of the of Canada is really an area of very high growth. This is a super high rate of development on one side of the border and not on the other. And so for species needing to move across the border, there are these barriers that are increasingly in place. If we wanted to go ahead and identify the last remaining really good linkages for wildlife across the border to prioritize where we should be working together to maintain permeability across the border, we have this problem of our data presenting a barrier, because often people do analyses on one side of the border or the other to identify important areas for connectivity or for climate change, and they don't cross the border, or they're completely like apples and oranges. So even if they stop at the border, you can't just stitch them together. They're not the same kind of analysis, and so our data is presenting a barrier as well. And then finally, we have some barriers in sort of governance and institutions. So people aren't necessarily talking across the border. So I'm a land manager or wildlife manager in Washington. I'm not talking necessarily to my counterpart up in British Columbia. Our policies aren't necessarily talking to each other. So we have all these barriers in place to actually having a really well-connected, resilient transboundary region to allow species to move and to allow them to move under climate change. And so to address these various barriers, I started the Washington British Columbia Transboundary Climate Connectivity Project, and this was funded primarily by the Northwest Climate Science Center, but also by the North Pacific and Great Northern Landscape Conservation Cooperatives, and also Wilberforce Foundation. And the goal of this project is to engage science management partnerships to apply the best available science to promote a resilient transboundary region. And I'm saying available because we're not creating any new models here. This project was based off of some scoping work we did a couple years ago, where we were asking land and wildlife managers in the Transboundary region, what do you need? What models do you need to incorporate climate change into your management of connectivity? And the resounding response we got was that we don't need any new models right now. We don't even know what to do with models that are out there. What we need help with is accessing, interpreting, and applying climate models to our work. We just need someone to help us figure out what these things mean. So we said, okay, we'll have some science management partnerships and we'll sit down together and we'll figure this out. We'll figure out what you need. And so we realized that the answers might be different depending what scale of management you're looking at. And we also wanted to address some of those barriers to management. So we put together these nested transboundary partnerships. At the largest scale of, let's see if this pointer works, probably not. So the black outlined area, the whole large transboundary area on top there, that partnership at that largest scale included the U.S. Forest Service, the National Park Service. To the north, it was BC Parks and BC Forest Lands and Natural Resource Operations. Nested within there, the red area in the middle there, it's sort of Okanagan to Kettle Mountain area. That we partnered with the Washington Habitat Connectivity Working Group and its partners in Canada. So they were doing an operational scale analysis of connectivity priority areas in the Okanagan Valley, that area I was telling you about, the Palm Springs of Canada. So that is a major pinch point for movement across the border. And so we were going to help them include climate change in that analysis. And then also nested within that Okanagan to Kettle region, we have the Okanagan Nation to the north and the Colville Confederated Tribes to the south. So the areas in purple show their reserve and reservation lands, but we actually were working with them more on the scale of their traditional territory and usual and customary, which is much larger than that. And for all of these partnerships, the science partners were to the south, the Climate Impacts Group at University of Washington, where I work, and to the North Pacific Climate Impacts Consortium, PCIC, at University of Victoria. And so we have our own barriers. So we realized that our data often didn't talk to each other. And in some cases, it was pretty easy to get it to talk to each other, and we could do it during this project. And in other cases, it was a good chance for us to talk and see what we could do in the future to get our data to talk better. So set a research agenda, compare notes on how we do this kind of work with each other. And I'll also say that those three partnerships, so much of what I'm going to show is like, how it all was set up on paper. And in reality, there are people who wear many different hats out there and are operating at all three different scales and wear hats within these different partnerships. And so it actually was very fluid, the whole process. So again, nice and neat on paper, how we were going to set up these partnerships and how this process would proceed was that we would have a series of workshops. Whereas in the first workshop, we'd sit down with the managers and say, what do you do around connectivity? What decisions are you making right now about connectivity? What are your goals and objectives, and what kind of actions do you take? We then stepped back and did a series of sort of iterative analysis, identifying the potential climate impacts to connectivity and their activities around connectivity. And then we had a second round of workshops where we sat down and said, okay, well, here's those impacts. How would we address them? What's in your toolkit to adapt your management of connectivity to climate change? Then we had a second round of analysis, and this is actually where we are right now. We're finishing up right now, finalizing our products, so putting together everything we heard from the managers and all of the data that we have to give them a set of decision-relevant maps and data around connectivity and climate change for their decision-making, and also all of the adaptation strategies that they put together, with delivering all of this scheduled for this February, and then a series of workshops in March. So what does this actually look like? This is what a workshop actually looks like. This is a bunch of scientists and managers. There's actually several of these tables in the room. This is the parks and forest folks sitting around a table with a ton of maps and data saying, okay, you want to know what climate impacts are going to be on your landscape and how that's going to affect connectivity. Here's what we actually have available for you. We drew really heavily on a few main data sets. So the Pacific Northwest Vulnerability Assessment, which very soon we'll have online a ton of sort of range shift maps and various maps of changes in species distributions due to climate change. We had all of the corridor and connectivity maps of the Washington Connected Landscapes Project. And we had many different climate maps that were put together by PCIC and SIG, the Climate Impacts Group, that we worked together to get to be transboundary. And this is actually a picture from the second set of workshops where we put our adaptation strategies together. And this workshop, we had a lot of of notice. You'll have, by the way, this will be held in June, and you've got like 6 months to figure out how to get here. But when we first started the project, the way that these things work, you're waiting for the money comes in, you got to start up right away. And so we wound up immediately running into one of these barriers to transboundary work, which was getting people across the border with just a month's time. And so we wound up doing things like this. So this is actually you can see the little Canadian and US flag in the background there. This is the I-5 border crossing. There is a peace park there with like a little tiny facility they called American Kitchen. We like met in this kitchen, and this is the only way we could get people in the same room together to talk about transboundary connectivity and climate change, was to like meet at the border, so they never had to present a passport. So these barriers, actually, it should not be this difficult to get people across the border to talk to their counterparts. It's the only way to do this kind of work and build this trust and these relationships so they can interact and coordinate their management. We also, another issue, another barrier we came across in just doing this work was that we had all these disparate partners. We had forests, we had parks, we had First Nations, and NGOs, and getting them, we couldn't possibly have the capacity to, for each of these groups, put together a whole process like this for their individual priorities or mandates. And so we had to work with them to come up with some shared priorities that we could focus on for this work. And that can be kind of tricky because, especially when you're talking about wildlife, many of the species that we care most about, it's because they're at the southern edge of their range. So lynx, really big deal down here, they really don't care up there, and vice versa. So things like tiger salamander at the northern extent of the range up there, big deal in Canada, not as much a big deal down here. So there was a little bit of sort of haggling, and like we'll give you lynx if you give us tiger salamander, and so we have some of the big carnivores in there. We've got the bear and we've got wolverine, but we also have bull trout in there, and we have some vegetation in there, and there was also some pretty interesting science manager haggling, because the managers really wanted some things that were kind of beyond the scope of what we were doing. Like they really wanted Lewis's woodpecker, and I'm like, connectivity, not really an issue. They can fly, not an issue, but they really wanted it. So I was like, okay, you can have Lewis's woodpecker. So a lot of haggling, but we came up with some shared priorities. And then the next barrier was our data, which is that, again, a lot of the data that we have around connectivity and climate stop at the border. And so we had to come up with an analysis framework that could accommodate a lot of different kinds of data, and data that wasn't necessarily transboundary. So eventually what we came up with was to start by developing a conceptual model of connectivity for these species. And this looks busy, it's really not, and in fact it's one of the less busy ones, but this is for wolverine, and we said, okay, what we want to know, how to make this very 30,000 foot problem tractable, is what really matters for connectivity movement on the landscape. What are the landscape features that affect whether a wolverine can move through the landscape or not? And what are the processes on the landscape, like drought or fire, that might affect those landscape features? And then where does climate affect each of those? And then where do people affect each of those? And once you do that, you can get a sense of how climate and connectivity both interact to affect wolverine, and where people come into the picture, and we can actually intervene in any one of those things, and also where we have data to address any one of these things. So once we had these conceptual models together, we could sit down with the impacts and the climate projections and say, okay, what is going to happen for these different processes that will affect wolverine connectivity? So we could identify the impacts that really matter for wolverine. And once we had those identified, we could come up with some actual adaptation strategies. And so, for example, for wolverine, and for all of them, we divided them into two things. One, actions that address loss of connectivity due to climate impacts, and then actions that provide the kind of connectivity that will be needed under climate change. So connectivity that spans temperature gradients, connectivity that will help promote movement from current to future ranges or areas of climatic stability. And so the kinds of things that we have in here, for example, this was exciting for me because I care a lot about connectivity and climate change, and one of the things that's very frustrating is it's this very 30,000 foot concept, connectivity, really important for climate change. It's in like every federal management plan about climate adaptation. But getting that from that 30,000 foot mandate to something very specific on the ground is an extreme challenge, and this was an attempt to do that. And so for wolverine, for example, snow, like decreased snowpack, could lead, the impact, one of them could be increased access. Suddenly people can get places they couldn't get before. Maybe roads open early. That's very specific. What could you do about it? If human activity is something that deters wolverine from moving through the landscape, then you could do something about it. You can manage your roads, thinking about changes in winter recreation. If you have loss of core habitat, you could think of how to manage snowpack or change your priority areas for conservation for them. So we had some very specific impacts and specific actions you could take to address those, and also to help promote wolverine movement. And then to prioritize where on the landscape to implement some of these things, you could do things like look at a wolverine corridor network this is produced by the Washington Connected Landscapes Project. The areas in green are current core habitat for wolverine, and the glowing areas in between them are the best or the least cost linkages between them, the easiest places it would be for wolverine to move between core habitat. So maybe you want to implement some of these things in these remaining key linkages. There's other ways you could also prioritize where to do these actions, like looking at areas of future projected stability for wolverine and really making sure that connectivity to those areas is maintained. So in summary, in my experience with this project, I would say that transboundary climate connectivity conservation really relies on a lot of cooperation, flexibility, and persistence. So first of all, you can really help foster collaboration and address some of those barriers across the border by focusing on shared priorities across the border. Persistence is incredibly important to get people to the table and to get them to participate and being flexible and coming up with creative solutions to get around some of those institutional barriers to getting people to work across the border. And then also, because we have such diverse and often incompatible data sources or missing data, having an analysis framework like our conceptual model framework that can accommodate and leverage diverse data sources is also really important for working across borders. And also thanks again to the people who funded this work. And I'll take any questions.
So I imagine that on one hand you're trying to balance, having a productive project and, managing a smaller number of agencies. In retrospect, do you feel like you were missing anyone from like the state perspective, or state lands, natural resource managers, water managers, other federal agencies?
Sure. So the question is, did I feel we had a pretty small number of partners in the scheme of things in terms of who's actually involved in managing the landscape, and did I feel like I was missing anybody by not including like the state or water managers and others? And I would say that for this project, this is actually pretty novel, trying to take that concept of connectivity and put it down into these really on-the-ground actions. And I would say that I am extremely grateful we didn't have more partners in this process, because it actually made it tractable and nimble, and it needed to be all of those things. And so for this iteration, I'm very glad we didn't. That said, I'm looking to this project to lay the foundation for a much larger effort to look at priority areas for climate change, which would include connectivity across this transboundary region. And that would have to that's one of those, like Crown Management Partnership or something, like bringing everyone to the table to try to come up with some shared priorities at this scale. At a finer scale, you could have completely different priorities, and that's fine. But I think at this like large scale needed for climate change, you do need everyone at the table. But I'm glad I did not do it here. Yeah.
Okay, I'll just ask.
That's okay.
So you mentioned differences across the borders, and this might be a little bit of a outside the realm of what you did, but with land management, I know, in the Okanagan Hill area, they've been trying to restore fire to the system in south of the border. Are they doing that in Canada, or what's their approach?
Yeah, I don't think I can speak to generally what is going on north of the border in terms of fire management. I mean, we certainly talked a lot about the impact of fire on connectivity and things that you could do to address that. But it totally varied by agency. So I don't know that I can answer exactly what the general strategy is north of the border for fire management, or how it would influence this work.
Hi, I'll just holler. So you did mention a lot of this was terrestrial, but I saw some fish in the picture.
Yeah, we have bull trout.
And so I'm interested to what extent did transboundary rivers and actually like in-stream quality factor in? Because there's been past issues.
Yeah.
I mean, some rivers go north, some rivers go south. So that's been a troublesome area in the past.
Yeah, I mean, on the one hand, I would say that so I was just at a science forum around the management of a transboundary lake that had like the International Joint Commission there and others a couple of weeks ago. And I would say that in general, the fish people are like miles ahead on this because there are so many treaties in place that specifically address waterways, transboundary waterways, and transboundary fish management. So, our dealing with bull trout was mostly looking at things like, where are the cold water refugia projected to be? What different things could you do to maintain connectivity in light of climate change for bull trout? But I think that that work was actually in many ways way less needed because there's already been so much good work done with the fish. The terrestrial management, that is so much more challenging because there's so many different kinds of land ownership and mandates and priorities, and the barriers, I think, there's just nothing in place like those many treaties we have to deal with fish for the terrestrial guys. So I don't know if that got at exactly what you were asking, but okay.